Okay, so by popular demand, I'll take up CCC 20S3 for you guys. I did not mean to turn on my video, that'll just cause my bandwidth to go bad. Screen 1, start showing my screen. As soon as someone can see my screen, oh god. Can they confirm that they can?
I can see it.
Alright, good. And we're recording on our display capture? Yeah.
Yes, that's the correct one.
Yeah. Yes. Alright, now, because I am a freak, we have to make these indentations for. Okay, so let's have a look at CCC 20S3. Okay, so you're given a string n called the needle and a string h called the haystack, both of which contain only lowercase letters a through z. Write a program to count the distinct number of permutations of n which appears as substring of h at least once. Note that n can have anywhere between 1 and n factorial, or the magnitude of n factorial, or the length of n factorial, distinct permutations in total. For the string, for example, the string AAB has 3 distinct permutations: AAB, ABA, and BAA. And our restrictions are n is greater than or equal to 1 and less than or equal to 200,000. Same restrictions for h, and these are the partials. And then these are going to be our simple inputs. And yeah, let's get started. Okay. All right. So let's put that on the side. On a day that I could type, that'd be very great. All right, just putting our template code. All right, so let's just get our input stored. These n and h variables. I'll just declare them outside of int main just in case I decide to use them somewhere. So ints n and h. Okay, now take inputs. This is not int, this is string. Cn, n, and h. Now, I just realized you should probably have my other REPL open as well. Alright. So, our goal is to eventually have this polynomial thing, this polynomial for assigning a rolling hash value to a certain string. That's going to be our approach to this problem. And we went through everything, said that, and as a reminder, we said x has to be greater than 25, and the coefficients a0, a1, a2, dot, 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 to a of n are going to be the values of this string. It's the values of the character values, but we want to convert them to ints by doing the character minus minus a, because then that will give us a is 0, b is 1, c is 2, dot, 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 to z being 25, and these are manageable numbers. Okay, so first off, these x to the power of n things, if I go ahead and calculate them, as like if I calculate x to the n, and then x to the power of n minus 1, and then x to the power of n minus 2, and so on and so forth, I will have trouble. So instead, I want to, as a caution, I want to pre-calculate my values, values for x to the power of I, for I in range, this is Python syntax, in range 0 to length of string. Okay, and so let's go ahead and do that. So I'm going to store the array of powers as pows, and because the numbers can get really big, I'm just going to store them as long longs. And we might need more than one use case of long longs, so to prevent your fingers from hurting too much, I'm going to make a macro saying I'm going to define LL as a long. So every time I type LL, the compiler will read long. So I'm going to store the power array. And then for the length of the string was 200K. That means this size should be, I'll just make it a bit above 200K. Now, so you want to set our powers. Let's see. So obviously, x to the power of 0 is obviously going to be 1. Power array at 0 equals 1. And the simple thing we would do is for until I equals 1, I wish I could type, I is less than the size of this array, which I'm just going to copy. I plus plus. Now, we know that x to the power of, let's say, some value of k equals x times x to the power of k minus 1. By exponent laws, you have k minus 1 plus 1 is k, because you're multiplying with the same base. So instead of calculating x to the power of k by by putting some power, the default power thing is plus plus, I'm just going to relate the value at k to be power of array at I to be power of array of I minus 1. This is saying x to the power of I minus 1 times x. And remembering from before that we had x as a given constant, we said 25. And we said that choosing a prime value of x would be better. I'm just going to use something like 37. So up until this point, does anyone not understand what I have done? Can anyone actually hear me?
Yes.
Okay. So it seems like...
Loud and clear.
Okay, good. So it seems like we're good so far. However, there's one thing that we have to consider. It is that, let's say we have 37, right? We have 37, then 37 squared, then 37 cubed, and something like 37 to the power of 200,000 is going to be way above the limit for the long. So instead, I'm going to have to use a modulus. But instead of just using any modulus, I want to use the same modulus. I'll just copy this over here, actually. We said p of x had to be taken by a modulus. By a prime modulus. And so we should take the x values mod the same prime number so that the values of p of x don't change because the x power of n's are generally completely different numbers than what they should be. So I'm going to also make my I'm going to make a constant modulus value. So this is defined by const, and then the type, I'm just going to put long equals, and then the largest number, the name. And by convention, when you use constants, they're usually represented by all capital letters to signify that they're constants. And the largest prime that comes to mind for me, no one saw that, is 10 to the power 9 plus 7. So 1, 2, 3, 4, 5, 6, 7, 8, and then a 7. Yeah, my sister's a fan of BTS, if you guys didn't know. So instead of just doing power of array of I equals power array of I minus 1.
What's BTS?
You're better off not knowing. It's a boy music band. Boy band. Boy band. They do dancing and all that. They're really popular around the world. They're from South Korea. Whatever. That's not really relevant. But yeah, you just got a glimpse of what my sister likes. So power array of I minus 1 times 37. And then now we can do mod, and then this capital value of capital letters for mod. And then now everything will be under the limits for how long a long can be. Because something with 1,000,007 times 37, that can have that can't even have more than 11 digits. And I know that the unsigned long had, not the unsigned, the regular long has a value with something like 18 digits, I think maybe plus or minus 1. So I'll be in the clear for sure on this one. So now that we set our power array, so that means now we've successfully determined all the x values that we're going to need. Now we have to find a way to generate a permutation. So find a way to check permutation. Check if one string is a permutation of another. Really fast. Okay, and just to remind myself, n. Okay, so n is the smaller string, the thing that we're trying to see how many permutations there are. Okay, permutation. Actually, let me reword this. If a string is a permutation of another, what do they have in common? This is one of the key things that you need in order to solve this question. So someone give me the answer. If a string is a permutation... Pardon?
Can I answer?
Let's hold off because you've already solved this question.
Okay.
If a string is a permutation of another string, what do they have in common?
Do you want me to answer?
Have you solved the question before?
No, I actually haven't.
Okay, go ahead.
Both of them have the same amount of each of the letters.
Yeah, the frequency of each character is the exact same. Swame. Okay, the frequency of each character is the exact same. In other words, they'll have the same number of A's, the same number of B's, the same number of C's, and ... to having the same number of Z's. In short, they'll have the same, the frequency of each character is exactly the same in both strings. And we also know that if a string is the permutation of another, they are of the same size. Because some of the frequencies obviously has to work out like that. So they're of the same size. So the idea behind this question is we have, let's just call the size of n as n size and size of h as h size. So we need to consider every possible, and since this is permutations that appear as a substring, we need to consider all the possible substrings with the same, consider all substrings of h that have the same size as n. In other words, equal to n size. Check if their frequency is the same, frequency of all characters. And if so, we have to store the permutation somehow. And the storing of the permutation, let's have a look real quick. N can have a size of 200,000. H can have a size of up to 200,000. Because we know that comparing two numbers is a lot easier than comparing two strings, because two numbers are compared by their bits, not by what do you call it? The number by every single character. Whereas a string, it compares every single character to determine equality. Storing the rolling hashes of each of the strings is easier to do and will be under time and memory constraints. Store the rolling hash values. And that's where our knowledge of the rolling hash is going to be implemented. But that's going to be the last step. So now we see that we need to consider all sizes, substrings of h. So that means we have to go from 0 to n size, 1 to n size plus 1, or substrings of h to consider. 2 comma n size plus 2 comma dot 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 all the way to h size minus n size comma n size minus 1, because we don't want to go not n size, h size minus 1. So these are all the possible substrings from the index of the left to the right, and you obviously notice that the left side is increasing by 1 every time, and similarly the right side is increasing by 1 every time. Plus 1, plus 2, dot 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 to minus h size minus 1. So that's the substrings of h we have to consider. Any questions up until there? Okay. Remember, if anything is wrong or you don't understand anything, feel free to blurt out whenever you want, or whenever I give us designated time to ask questions. Either way works for me. I'm not going to be offended by you asking questions. I'm going to be more happy. Okay. So, now here's one thing we can take care of, take in consideration when getting frequencies of characters, of the frequencies of every character in the substrings. So let's say I have A, B, C, D, E, F, A, B, C, D, E, F, and I'm looking at strings with size 5. So the first one I'm going to consider will be A, B, C, D, E. The second one I'm going to be considering will be B, C, D, E, F. If you take a close look at those substrings, you see that the B, C, D, E is going to appear in both the substrings. And then the only difference between the two strings is that there was an A in the beginning, but now there's not in the second string. However, the last thing has an F, whereas the other one does not. So that means the frequency of every character is almost the same between two adjacent substrings. Or not two adjacent, two index adjacent substrings. So the substring from 0 to n size and the substring from 1 to n size plus 1 will have almost the exact same frequencies, with the one difference being that you're taking away this A and you're adding an F instead. So if we had some sort of for loop, you just say frequency of string of current index plus or equals 1, and the frequency of the string at current index minus, and then you'd have to go back the length of the string, which is 5, because if you go back 5, you're going to 1, 2, or go back 5 from here, this character, you have 1, 2, 3, 4, 5. So this character, well, the A that you're going to remove, current index minus string size, minus equals 1. And if you do that, like you move from one to the next, the only difference in the frequencies is that is this. The current index string is going to be adding 1, whereas the one from back and before that got eliminated, it should be minus 1, because you removed the character and then suddenly you added the character. So those are the only two differences between the frequencies. So, let's go ahead and actually start doing some stuff more with the actual problem itself. And I think it's a good idea to actually use the same variables. Int n size equals n dot size, and h size equals h dot size. All right. So the first thing we want to do is create our we should create our frequency array for the n thing, because we're going to be comparing the frequency of n's, the n things, with all the different substrings of h that we need to consider. So build frequency array for n. Okay, Replic's not the best, but all right. So int, and I'm just gonna call it int nFreq with the size of 26. So that means the frequency, because there's 26 characters in the alphabet, so the getting the frequency of each character and storing it in nFreq. So now let's go ahead and implement that. So for int, now we need to loop through all the characters. Let's just do a character loop. For Charcy, I don't know if, can you do a for loop like this with strings, or am I incorrect? Kevin?
I believe so.
Okay, yeah. I mean,
Because string has begin and end.
huh?
You can do it like that.
Okay, yeah. Well, worst case scenario, it doesn't work, we change it. So for every character in n, actually, before we do that, one thing that I want to make sure I do is I set all the frequencies to 0 before I start. So memset nFreq, because it's 0, I can just use memset, and it's not going to have some strange behavior. And if you don't remember this, you can just do a for loop for int I equals 0, I is less than 26, I plus plus, and set the nFreq at I to be 0. That's the same thing as just doing memset nFreq 0 size of nFreq. So for every character in n, I want to add its frequency with an integer index. So once again, we need to do the character minus a sort of thing. So nFreq at character minus a plus plus. That's going to be, for every character, you're converting it to its index. So it's going to be an integer from 0 to 25 inclusive. And then you just increment the frequency by 1, or just doing plus plus. That's a thing in Python and Java and other languages. It's not in Python, Java. In C++, Java, and other languages, but unfortunately not in Python. So that's going to be our nFreq. Now we have to do, we want to build our frequency array for for each of the substrings. So I'm going to just call it int hFreq. And this is frequency not of h, but instead the current substring of h that we are considering. All right. So let's go ahead and get that started. So we want to add the first n size characters to our, we want to consider the first n size characters in h, because we want to just have our first substring of 0 to n size. And now I realize that this is actually n size minus 1 and n size plus 1, because string indexing is indexed by 0, not indexed by 1. So I made a mistake there. My bad. So we want to consider all the characters between 0 and n size minus 1 inclusive, or simply 0 to n size, not including the n size. So for int I equals 0, I is less than n size, I plus plus. Now we have to add the frequency of the character, and once again, I should set the frequency to be 0. In size of memset hFreq 0, size of hFreq. So now we want to add for every character between 0 and not including the n size. We want to add the character at that spot. We want to add its frequency by 1. So we want to do hFreq at, now we need to get the index h of I minus a, because we're converting it to a number again, plus plus. Okay, so now this is first substring to consider this is the frequency array. So the first permutation, we know that if two strings are the same, we have to add it as rolling hash value. So that means we need to compare and check if two substrings have are the exact same frequency. Okay, so for ints, so that means you have to loop through all the things. I'm not sure if you can do Kevin, can you do array equals between two arrays that have the exact same values and it'll return true?
Equals. I'm not sure about C arrays, but you can do that for STD arrays.
You can't for C arrays.
Okay, so that means we have to loop through. In Python, you could just use your list and
Lexicographical compare.
we're just gonna do our simple for loop here. So now we just have to just compare every index and make sure that they're the same. So if hfreak, so here's the thing, right? We have to check if all the characters are the same. So as soon as one of the characters' frequencies are not the same, we can just break out of the for loop. So let's have a thing as boolean. We'll have a boolean to store that they're the same bool permutation. Let's say equals true. And as soon as we find where the frequencies are not the same, we can set permutation to false and leave our leave the for loop by just breaking out of it. So if this is not if they're not equal to each other, if hfreak of I is not equal to nfreak of I, then we can set our permutation as false, and as a result we can just break because we don't need to check anymore. And so with this, what we're saying is for every character, if the frequency is ever not the same, we can just break out, say it's false. That means they're not permutations. But that means that if this is never satisfied, that means all the frequencies were the same, and hence they're a permutation. The substring that we considered is actually a permutation of n. So that means that if permutation, you want to insert the rolling hash value. And we'll actually worry about the rolling hash till later and how we're going to store it and everything, because that's a whole nother thing that we're going to have to consider. So now we found our first window, 0 to n size minus 1. Now to transition from 0 to n size minus 1 to 1 comma n size, we said that the frequency is you add the frequency of the current index and then you subtract the frequency of the index from before of the character that was removed. So we have to go ahead and do that now. Now we have to do for int, and now I'm going to call this idx, short for index. For int idx equals, and the first character we have to add again is n size. I is less than h size, I plus plus. So now we have to modify the frequency. I used idx, then I switched to I. Modify the frequency array. So, does anyone want to give a shot as to how I'm going to modify the frequency array?
Can I answer?
Go ahead.
You remove the index of the frequency array from the first letter. I mean, you remove 1 from the frequency array at the first letter, and you add 1 from at the frequency array at the letter that's getting added into the substring.
Yeah. Good job. So that's going to be working with hfreak because that's the thing that's changing. Hfreak of idx, the current new character, we have to add its frequency by 1. Nope, we don't do that. We have to add the character's frequency by 1, not the index's frequency by 1. Hfreak at h of idx minus a plus plus, and we have to remove the one of the frequencies. We have to subtract 1 from the frequency of the character that left. So h freak of h of, now we have to go back from IDX, we have to go back minus n size in order to get the character that was removed. Minus a minus minus. Somehow plus plus works, minus minus means subtracting 1. So we're modifying our frequency array, and now all we have to do is simply check if it's a permutation again. So we already have our permutation variable up here, so I don't need to write bool, otherwise the compiler will tell me to not do that. So once again, I'm going to assume that the permutation is true at the start, and then simply check. And the indentation is messed up, and that should be good. So now we have if permutation, blah, 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 blah. So now this will go through all the possible substrings, modify the frequencies, check if they're the same, if those frequencies are the same, now we have to insert a rolling hash value. And then our output is number of different substrings, or permutations, my bad. And here's the thing. When we do a rolling hash, even though the frequencies of all the characters are the same, the rolling hash also depends on the location of each of the characters. So assuming that there's no collision from the modulus, two characters that have their two strings that are permutations of one another, they'll still have different rolling hash values, and that allows us to distinguish the different permutations, but also clarify that two of them are the same. So that's what we have to do. So now we have to implement the actual rolling hash itself, and this is where it gets interesting. Sorry, I had to take a sip of water there. We need to create our make hash value, or long create hash of a string. Okay. So now we use our polynomial expansion, and then we go ahead and create the rolling hash. So we first want to optimally create the rolling hash value for our n, because we have to compare everything to the rolling. We want to compare everything with the rolling hash value of n in the end. So it's actually, it doesn't matter. We'll just do it first anyways. Wait, no, that's actually false. We shouldn't create the rolling hash value of n because it's not even necessary. All right. So now we have to create the hash for a value n, or a string value s. All right. So let's store our value to return as val, and we'll set it equal to 0 at the start, and at the end we want to return the value. Okay. So we want to go from it for int I equals 0, I is less than s dot size, I plus plus. Now we want to just simply add the rolling hash value. Let's see now. Val plus or equals, and now we have to use our power array that we've successfully generated before. Val plus or equals power array of I times. Now we need to convert the character into we need to convert the character into an index. So the character, the s at I minus a. So what we're doing is we're converting it to an index from 0 to 25 by doing s at I minus a, and then we're multiplying it by the power array, so that for every point, for every value of I, we're doing a of I times x to the power of I. And that's essentially the rolling hash. But obviously we have to, we should take this modulo our big mod number, and then at the end you return the val. And just in case it overflows, at every point we want to do val equals val mod mod, just in case it overflows, so that it doesn't continue to overflow even though the numbers are all less than 10 to the 9 plus 7. Okay, so we have val equals val mod mod, and then we want to return the value. So at every point, or every thing here, we want to insert the rolling hash value. But how should we store it? The simple answer is to use something that C++ has called an unordered set. And then this will be of a type long roll hash values. So if you guys remember from grade 11 computer science or junior computer science club, you probably learned about the set in Python, and this is the equivalent to that in C++. The unordered set, and then in angle brackets the type, and then the name. There's also a set in C++, but it does not. It is not storing one of each frequency, and it is also not as fast because it maintains order. So for this one, we want to use unordered set. So that means that there will be no duplicate values of the rolling hashes. So now we just want to simply add our rolling hash values to that set. So roll hash values dot, and then we just have to insert. Well, we don't need to do that. Rolling hash values dot insert, and then we have to insert our string. So we have to insert our rolling hash value. So we have to create hash of the current string. And because we're looking at a certain substring only, we'll just do h dot substring 0. Oh, this is capital H. H dot substring 0, comma, is this index based or Kevin, can you remind me, is this index based or is
It's
it
the length. It's the length.
all right? 0, comma, the length is obviously n size. So that'll be our rolling hash thing, and something is up here.
It's substr. It's substr without the ing.
Oh, okay. So Replo is wrong. I was kind of suspicious. So same thing here, except that instead of doing that, we want to go from the back. We have idx minus n size plus 1, comma n size, because then that'll bring it up to that'll be the first character because we're going back n size and adding 1. So we're going from the starting character to with a length of n size. So that's how substring works. And if ever you don't know a method, either check the autofill or just go on c++.com or CPP reference, and they'll be there. But since I'm teaching a class, I just want to make it so that I didn't have to go and do that while I'm teaching. So now our roll hash values, unless I've done something wrong here, this should work. This should work as the total number of permutations. So cout roll hash values dot size, and that should work. That's what every computer scientist says, and then sometimes it won't work. So let's go ahead and run it.
The amount of times it didn't work for me.
It's crazy. Anyone can relate.
Can't remember how many attempts it took me to get this.
All right, so this is 2, and that's the correct answer. Now, let's go ahead and actually try submitting this. See if it works. If not, then someone hopefully knows what I got wrong, or I figure it out really fast. Otherwise, we'll have to wait. Oh wow, it's actually working. And we TLE'd. So that now that I think about it, I actually kind of expect it.
Mm-hmm.
And that is because, if I'm not wrong, if I'm wrong, someone please correct me. It's because every time we're passing the string and then we're converting it to a rolling hash, instead of finding some way to make the rolling hash value easier to just convert right away. Am I correct? Or am I wrong?
Yeah, that is why, because you're hashing it on the spot. You're not rolling the hash.
Yeah. Yeah, so the idea of rolling the hash is we have to use our previous hash value and somehow make it so that our next hash value works. All right, so how do we do that? Let's go ahead and see. All right. So, let's copy our polynomial again. And so for a character in there, p of x equals, let's say we're going for, let's say we are going to up to, or to a size of n, lowercase n. And okay, so we should ignore this x power of n. Actually, that's good. Actually, this is a of n minus 1 times x to the power of n minus 1. So that would be, if we were going up to a size of n, that would be our value of the rolling hash. Now, we need to do something else if we even want it. We want to have a chance for it to work, and that is for the next substring. We know that p of x is equal to a1 of, and this time we have to remove the x, times a2 times x times a3 times x squared times dot 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 times, and this will be up until a of n times x to the power of n minus 1. And the reason we do this is because we're limiting the first character and introducing another character, which is the n plus 1th character, which in string indexing is n. So how do we go from this value of p of x to this value of p of x? That is what we have to see now. Evan, what do you think is the fastest way to go from this value of p of x to this value of p of x? I just guessed that Evan was here. And he's not. Okay, because then he would have seen it right away. Anyone else want to give a try? What do you think is the best way to go from this number to this number? Recognize that what we've done is we've taken our x values for a1, a2, a3, dot 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 to a of n minus 1, and the power on the next thing is 1 less.
You can first you remove a at 0.
Yeah.
You divide the whole thing by x, and then you add a at whatever to the x to the n minus 1.
Yeah. All right. Now, there's only one issue with that. What he said is almost he was essentially correct in the situation that was given. However, there is one problem with this. It's that p of x, I actually forgot to put this modulo the big mod number. Mod. We need to talk about something that's wrong with dividing when there's a modulus. Let's say we have 6 and p of x, or old value of p of x was 6, except that we had to take it modulo 5, and that had to equal 1. Or anything, or like something that has a value of 6, and then because of modulo 5 it equaled 1. Now if you wanted to take that value and you divided it by 2, if you divide 6 by 2, you would get 3. If you divided 1 by 2, however, you would get 0. The thing is that you don't know how much the modulus affected the total value of p of x because you've already taken a modulo mod, or capital mod. So we can't determine how much the effect has taken on p of x. So that means that when we subtract a naught, and then he's right in this case that we have to divide by x, dividing by x, we can't necessarily that the result is the correct result because p of x was taken modulo some huge number, which means that it will actually mess up with the entire modulus. So that means that means that the p of x that we've made is actually not good. It won't work well. So now we have to think of, for this question specifically, we have to think of a different way to represent our p of x value. And now Kevin, you tell me, what do you think we should do differently for our p of x instead of doing what we did before?
Since you're mod in the mod world, you can divide, instead of dividing by a number, you can multiply it by the divisor's modular inverse.
Yeah, that is true, but that is way too much work. So instead of changing and we're going to have to change the method as well, but what can we do to make the method of transitioning a lot easier? What can we do to p of x? What should we use for p of x instead? Because clearly we saw that with our current value p of x, transitioning to the next rolling hash value is not going to work.
Do you still want me to answer?
Yes.
Oh, you just do it with the first coefficient being the first term being the highest term code. The first term being the highest term instead of the last term being the highest term.
Okay, and that is correct. Now we have to analyze that. All right. So I'm going to write this down, then show you why it works. And for those who attempted to solve a problem and didn't get it, that is perfectly okay because this problem was quite weird if you have never seen the rolling hash. X to the power of 0. This is actually just a of n minus 1. All right. So now let's take it differently. Let's reverse all the order of which we put the exponents of x. And in this time we put a naught x to the power of n minus 1 plus a1 x to the power of n minus 2 plus a3 x to the power of n minus 3 plus dot 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 to a of n minus 1. So this is obviously for a string of size n. And now, namespace n. Now, if we attempted, and this is all modulo mod. Now, if we attempted to go through for our next character, we'd have to do almost the value is almost the same, except the coefficients are moved forward 1 because we're going back to forward. A2, A3 of x of n minus 3. Oh, this is actually a mistake. This should be a of a2, and this should be a of n. So we went from p of x is a naught x to the power of n minus 1 plus blah 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 blah, and then from that we go to this. So now we have to now let's see if going from one to the next is going to be easier than the previous one, because Kevin introduced the way that we use the modular inverse of all the factors, which is valid, except it's way too much work to do. So we'll try using a different method of p of x. So Arslan, I'll use you again, and I promise you this won't lead into a loophole again. what do you think that we should do to get from this value to this value?
You can do the same thing. You can just remove the first one.
Yeah.
And then divide by x.
You sure it's dividing by x this time?
Almost. Wait. Is it multiplied by x?
Correct.
Okay, cool.
If you take this out, multiply by x, this a1 of x to the power of n minus 2 becomes this a1 x to the power of n minus 1. This a2 to the power of x to the n minus 3 becomes a2 x to the power of n minus 2. And so on and so forth. And then after all of that, Arsenal was definitely going to get there. You add a of n, or value of a of n. Let's write that down. Previous p to the next. We have to subtract a naught. Oh shoot. A naught x to the power of n minus 1. Multiply the remaining hash by x, and then after add a of n. And this will be what and the reason why this works is because a times b mod, our big number mod, is the same as a mod times, like, yeah. Wait a second. A times b mod is this mod, our modulus value, which is in this case mod, will actually match up because a mod times b mod. Actually, it's just percent signs because we're computer scientists. Where a and b, where our a value is a1 x to the power of n minus 2, a plus a2 x to the power of n minus 3 to a of n minus 1, and our b value is x. And that so that was our p of x, but then we had to modulus, take that modulus, the mod number, but subtracting is also fine. So in other words, when you divide, you can't guarantee that you're going to be dividing correctly because you don't know how much it was taken away. When you multiply, it doesn't matter how much it was taken away because it's the same as doing multiplying the moduli individually and then multiplying the two values out. So now we want to go ahead and do that. So our power array, it still works, obviously, because it's still the correct powers. However, now we have to find a different way to create our hash, because instead of a naught x, instead of just a naught plus a1 x, we have to reverse the exponents. So instead, our power array index has to be different. And because we were considering a string of size n, and all strings that we would pass through create hash are going to be of a size n size, because that's the size of the permutations that we're considering, then that means we can do something similar to just power array of n size minus I. Because we go from a naught, our I value is 0, and then that actually means that we should make this global. Let's do that. And that's why you should make your global, more of your variables global, because this allows for easier access. N size minus I, but that'd be n minus 0, so we have to subtract 1 again. Power array of n size minus I minus 1. So that means the exponents will be reversed in comparison to, like, the I values going up. N size minus I minus 1 will be going down. Are we clear up until there? Because I just realized I forgot to ask if we were clear for a very long time.
Crystal clear.
Not my microphone. The concept.
Never mind.
Alright. Hopefully you guys understand it. Alright, so now instead of doing we changed our n size our values for the powers so that we use the correct ones. Just fix that real quick because we didn't declare h size to be global or anything, so we have to write int for that one. So now that we have this, we have to use that to somehow create our hash value. So first, what we want to do is the goal is to use our previous hash value to somehow create our next hash value, and we have our method to do that. Now we have to actually create our starting hash value so that when we go into our for loop over here and modify the frequencies, we have to change our hash value that we had before and modify it so that it becomes what we were going to have now. So first we have to actually store our hash value. So let's go ahead and do that. String, actually, long hash val equals, and then it's actually the same as this. Create hash h.substring 0 to n size. And then if it's a permutation, then obviously you want to insert that current hash value. So far the changes I've made have been quite insignificant because I just essentially stored a variable in a number over here, and then I call it using a variable instead of using the function call in the Arora hash values. But this, when we call them down here, this is where it's going to really matter, because instead of inserting the Arora hash value from actually generating it from looping through the entire substring, we'll instead just convert our previous hash value to our next hash value. So our first step we said was, let's actually copy it. Let's go over here. Just remind ourselves of the steps. Subtract a0 of x minus 1, or in other words, the character that has been eliminated to the power times x to the power of n minus 1. And then multiply the remaining value by x, and then add it. Alright. So h hash val, let's subtract our previous character. Hash val minus equals our character that's leaving, its index is going to have its value is going to be that, times and then we stored our powers as an array called power array. So power array, and since all the string sizes we're dealing with is n size, really, we can just power array of n size minus 1. So that's our first step. Hash val minus equals h index minus n size, and then all minus a times power array of n size minus 1. And to make sure that this doesn't go to negative, we'll actually put this modulo mod. However, C++ modulus, unlike Python, I believe, which makes it, which always makes it into a positive, if it goes into the negatives, it will just become a negative value that's that's greater than negative 10 to the 9 plus 7. So what I mean is mod in taking, okay, comment that. taking percent of a negative number will result in a value that is in the range modulus value, because the negative modulus, because in the negatives it will just try to convert it to be the highest negative number, but for some reason it will still not be above 0. So in order to prevent any messing up, let's just convert into a positive number. And so if we take this inequality and add a modulus to all sides, we get minus modulus plus modulus is 0, and our middle part becomes value plus modulus is less than or equal to modulus. And our value is negative and our modulus is positive, so that means it will definitely be between 0 and modulus. And if we take modulo, and so if we do value plus modulus, mod modulus, then it will be between 0 and up to, but not including, the modulus value. That's how moduluses work. So in other words, to summarize all of that, we'll just convert it into a positive value by doing hash val equals hash val plus mod mod mod. Any questions about what I even did there? Okay. So now that we added our hash value, now that we've removed the character, now we have to multiply the remaining value by x. So now we have to do hash val equals hash val, and our x value of choice was 37, I believe. Yes, 37. Hash val times 37 mod mod. And now we simply just have to add a of n, our new last character. Hash val plus or equals, and now we have to just add the last character, which is h of idx minus a. Just make sure that gets converted to an integer, so I just put it in brackets. So the 3 steps were to make it, remove the last character, multiply by x, and now add the value of the last character. And just in case it overflowed by this tiniest amount, we'll just do hash val mod equals mod. And now we can do our permutations. And then instead of creating the substring every time we want to insert a row hash value, we can instead use our pre-computed hash val. Because by doing all of this in here, we've transitioned our old hash value into our new hash character's new hash, the new string's new hash value, because we know that the strings are next to each other. So this should work. Let's make sure that this still works. Hopefully it does. And this produces an output of 2. So let's see. Does this work or not? If it doesn't work, this is all the optimizations that you need for this question. And if it doesn't work, I'll work on fixing it. And we W8'd. It's case 39, so it's very close to the end. If there's nothing right off the bat that I can tell, then I'll just go ahead and worry about it later, and I'll try to fix it as fast as possible and give it to you guys. I'll temporarily post this. Yeah, it got very close to the end, so it's probably a very small case that I'm missing. Or maybe it's even the modulus isn't big enough. So let's try another number for a modulus. Alright, so I just quickly searched on my phone another modulus number to use. 4465 4 641 650 887. 446 546 416 508 87. Alright, let's try submitting this. If this doesn't work, I'll just go ahead with the rest of the lesson and I'll fix this as fast as possible. And that actually worked. So what happened is, this is actually a good thing. Our modulus, wrong thing. Let's actually zoom back in. Our modulus that we used here was 10 to the 9 plus 7. This has 3, 6, 9, 12, 14 digits. It has a lot more digits than 10 to the 9 plus 7. So what happened is there was a collision. There was a hash collision, meaning that even after the modulus and everything, the numbers were still there were still two numbers that happened to have the same modulo value. So I just used a larger prime that I searched up, and it worked. So does anyone have any questions with the solution of this question? I know this was a lot. And to be honest, it took a lot longer than I expected, but this is actually better that we took longer because the longer you take, the more content you get. So, any questions from anyone?
If you're doing it like with the first term being the biggest term, I don't think you actually need a prime modulus.
Well, it can help. It's not something that will be a drawback, but it won't necessarily. It might not necessarily be a benefit, but it won't be a drawback. So yeah, the main takeaway here is our regular polynomial, which I said it would work, was actually a lie because transitioning from one character to the next was ugly. But instead, if we considered this polynomial with, this polynomial with the powers reversed, going from one to the next was so much faster. So yeah, this question was a lot of work. I congratulate Kevin for getting this right during CCC because this obviously took us a long time, and I've solved this question before too, and even I made mistakes. So yeah, this question was a lot of work actually. So yeah, anyone else have any questions or any concerns about the solution? I'll be posting it. I'll figure out a way with Gordon to post it in the GitHub, so that you guys can access it whenever you want instead of it getting lost in the announcements or senior chat. But yeah, if there are no questions, I'll make sure to put this in there. And let's see, it is 4:51. Okay. What do you guys think that we should do now? I'll put a poll.
Wait, are we already done with dynamic programming?
We got the basics done. Now, there's something I want to introduce. Definitely don't want to introduce it now because it's not going to be important. It's the quadrangle inequality. I've hinted at it many times with you and some others, but it's very, very complicated. Well, it's not too complicated, but the idea is so, it's not used that often. It just happened to show itself on CCO problem 4 from 2019, as well as CCC problem 4 from 2019. And then some other IOI problems and CCO problems as well. But I don't see that as a priority. So, okay. Poll. Do you guys want to go to the next lesson or work on problems? So I understand that this was a lot and that you might have some questions or some doubts. And the reality is, after this lesson, I feel like I was pretty clear on it. So you have to give a hand at yourself and try to understand it. But on the 4 problems previously assigned. Alright, so I'm going to put a poll in senior polls. That's not what I wanted. Alright. So go put your answer in that poll, because you may not be as comfortable talking or whatever, and that's okay. You might have your own reasons for not talking. I can't judge, really. So go ahead and put your answers in the poll. Do you guys want to go on to the next lesson, which will be binary search and some other work, or do you want to work on the 4 previous problems? Okay, we are getting a lot of people saying we should work on the 4 previous problems. So, right, so the 4 previous problems becomes 3 previous problems, really, because I'll actually work on posting this in the GitHub as you guys are working. But yeah, go ahead and work on the problems that were previously put there. If you finished all of them, or you felt like you've gotten a good idea on what the rolling hash is, and you don't want to implement, or like you've done at least 2 of the problems, then I'll say that you can, I'll give you some more questions, and you guys can do that. So any final questions with the stuff that we did today? Okay, if not, I'll stop streaming. And I'll get to posting that solution. I'll temporarily post in senior, and then I'll work with Gordon to put that into GitHub so that you guys can have reference to it. So CC23 S3 solution, ping senior. I wish I could spell. Alright. So, as a reminder, I'll post the problems again from senior resources. I'll post the 4 problems again. They're in senior resources if you guys don't want to look in senior, but I don't see why you care, really. So yeah, go work on those 4 problems. BF5, the one that you only use Python, seems to be a lot harder than than it might be. So yeah, work on those 4 problems, or the 3 problems if you just want to look at the solution and just copy it. But I recommend that you try to understand it and fully get it. Maybe even write it out to fully get the solution and be able to implement it in a good amount of time. If there are no questions, you guys can work on those 4 problems, and I'll be posting more problems right now, actually, if you finish those.